Was it just like showing pictures like this? Or did he actually go into like the actual dot product? Okay.
He was showing pictures like A, vector A dot, vector B. And he did like equals AB cosine theta.
Yeah, so this is kind of I mean, it's useful, definitely. So what happens is work is equal to force times distance. But only in the direction of the force. So let's talk about this for a second. So if you have a force that's pointing this way, so this is your force, and you go a distance s, like that, say this is like 5 newtons, and this is 23 meters. Then you can just do force times distance straight across.
Yeah.
So you do 5 newtons times 23 meters, so that's 115, not meters, 115 joules of work. But then what happens if you take this force and so now you have 5 newtons, and this is an angle of 60 degrees. How much work are you going to do now?
More work. Cosine of 60 degrees.
So this time, instead of just being able to say it's the force times the distance, you have to find the force in the direction of the distance, right? So there's a y component of this and an x component. So which one will you use?
The y.
Well, the y points straight up, so it doesn't go in the direction at all of the distance.
Oh.
So you always want to find the one that's parallel
Parallel
to the displacement of the distance.
Okay.
So what was that?
Oh, never mind, just keep going on.
So then you have this x component, and what's the x component equal to?
23.
Well, just the x component of the force.
Oh.
So you had a triangle like this. This was 60 degrees.
X component.
Yeah, so just this part of it.
It's 5.
Well, it wouldn't be 5, right? Because that's the hypotenuse. It's 5 cosine of 60.
Oh, yeah.
Okay, so once you have the force in the direction of the distance, now you can do exactly what we did the first time, right? Which is just 5 cosine 60 times 23.
Okay.
So the reason for the dot product is to show you that, or how you can do that. But when we do a cosine of theta times b, really what we're doing is we're finding the x component of a, or the component of a in the direction of b, like that. So this is a in the direction of b,
Right.
and that's a cosine of theta, just because this is a right triangle, right? And then we can multiply it straight to the b.
Okay. Makes sense.
And what does this one do, the component that's pointing straight up?
Like
Yeah, so you're pulling on it, but it's just moved straight. So does this part do any work? No. So that's how it works. So with work, if you're pulling on something in this direction and it moves that direction, so this is where it moved, then all of your force is doing work, right?
Yeah.
So it's most efficient if you can grab hold of a rope and pull straight on something, because all the force that you're doing is going into doing work on the box. But what happens if you're a little higher and you pull this way?
You have to put more force into it.
Yeah.
Pull the box.
So in order to do the same amount of work, you have to pull harder, because now some of your work or some of your force isn't doing any work. It's just getting wasted because you're not going to pull the box up into the air. And then what happens if, imagine that the box is just too heavy for you to lift and you're trying to pull it this way, you take a rope and you just grab it and pull straight up.
It's 0, so
Right.
you don't move it at all.
You know, it's not going to do anything. And then the same thing happens. Well, not the same thing, but if you start pulling on it this way, you'll do negative work. It's possible to do negative work.
Could take it in a different direction.
Yeah.
The direction you don't want it, I guess.
Yep. Or opposite the direction that it's moving. So say a box is sliding down a hill and you grab onto a rope and you start pulling it, trying to pull it back up. You'd be doing negative work, so you're like slowing it down. And work is basically how much energy you put into or take out of a system. So if it's positive, you're adding energy into a system. But if it's negative, you're taking energy out. So, what do you think about this? So the way it works is you'll always have a direction that the thing is moving.